Section 5.2, we're going to look at slope and something called direct variation. So direct variation is an equation in the form of y equals kx, okay, where k cannot equal 0. And we read this as y varies directly with x. And k in the equation is called our constant of variation. So you need to know these terms and know how we say this. Y varies directly with x. So for example, we can have y equals 3x. Since it fits this model, and since in this equation k equals 3, or the constant of variation is 3, we can say that this is y varies directly with x with a constant of variation of 3. Okay, so is this a constant variation? Or is this a direct variation? Yes, it is, because again it fits our model. And in this case our constant is k equals -4. Let me give you one more. What about this? Y equals 2x minus 1. This is not direct variation, because in our direct variation model we don't have plus or minus a number after our kx, so this does not fit the pattern. Sometimes we see them as a graph. So if we have this graph and it goes through, oops, I need to back it up. It does go through 0, 0, which is a good sign. So let's take a look at this. If I look at this equation and I count the slope, which is down 1 and to the right 2, okay, I can say that this is y equals -1/2 x. My constant of variation here is -1/2. It's very similar to a slope. We just have a special name for it when we look at direct variation. So let's take this a step further and let's look at graphing a direct variation. So for all y equals kx, or for all direct variation models, the ordered pair 0, 0 is a solution. So let's look at graphing. For example, oops, I lost my sheet. Let's look at graphing y equals 2x. Okay, so for y equals 2x, my constant of variation is 2, and that relates directly to my slope. So I know that 0, 0 is a pair, and if I set up a table and plugged in my values, and x is 0, y is 0, when x is 1, 2 times 1 is 2. When x is 3, 2 times 3 is 6. So those are some points. So I can start with 0, 0. I can either use my constant of variation as a slope and count up 2 and 1 to the right, or I can simply set up my table of values and plot a few of these points. 1, 2, 3, 6. And so this line passes through the origin at 0, 0, because every direct variation goes through 0, 0, and we can plot the points and graph it. So it's a simple graph. The other thing we're going to do is to write and solve direct variation equations. So if I give you this information, that y varies directly with x, so when I see this in a statement, I know that I'm going to use this model. So y varies directly with x, and I am given this ordered pair, y equals 28 when x equals 7. So that represents the pair 7, 28. So using that, I should be able to find my k value. So 28 equals k times 7, divide by 7, and I get k equals 4. So that tells me my constant of variation, but that's not my equation. I want to go back now and write an equation for y in terms of x. So back to my model, y equals kx, and now I'm going to use the k value I just found to write my equation. Okay, we will do a few more of these as well, but that's it for this video.